Hey students, welcome to mathgotserved.com. In this clip, we're going to be going over problems 21 to 30 of the Algebra 2 Practice Final Exam for Semester 1. Alright, let's take a look at question 21. It reads, given the general form of a quadratic equation x squared plus bx plus c equals 0, determine the effect of each condition on the solutions. So, before we take a look at the different conditions, let's do a real quick review on the discriminant. Okay, so the discriminant is given by b squared minus 4ac. And then there are three cases that tells you the nature of the roots that or solutions that a quadratic equation can have based on the discriminant. If the discriminant is less than 0, you have two imaginary solutions. If your discriminant is equal to 0, then you have one real solution. And then if your discriminant is greater than 0, then you're going to have two real solutions. Okay? Alright, so let's take a look at the different cases that we have here. Case number 1, we have b equals 0. But another thing to note is that for the given quadratic x squared plus bx plus c, in this format, we know for a certainty that a is always going to be 1. Okay, you have a 1 right here. So now let's take a look at the first case. B equals 0. So with b equals 0, a is also equal 0. 1. A is 1 as indicated here. So now what we're going to do is determine how this impacts the discriminant. Okay? In any of these three cases, if that solution or that inequality or equation is defined, then that type of solution will also be defined for the given condition. So let's take a look at what the discriminant is equal to in this case. So with b equals 0 and a equals 1, the discriminant b squared minus 4ac is going to be 0 squared minus 4 times a, which is 1, times c. Okay? And that's going to be negative 4c. Now, with this value of the discriminant, let's see what if it's defined in these three cases. Okay, so the discriminant is negative 4c. So condition 1 is where the discriminant is less than 0. So negative 4c less than 0. Are there any real values of c that can satisfy this equation? Is the solution to this inequality defined? Absolutely. If you divide both sides by negative 4, you're going to have c is greater than 0. Okay, so in this condition right here, we have 2. If c is greater, well, the discriminant is less than 0, so you have two imaginary solutions. Let's take a look at a second case. Negative 4c equals 0. Is the solution to this equation defined? The answer is yes. If you divide by 4, you have c equals 0, and this means that you have one real solution. Case number 3, negative 4c greater than 0. Is the solution to this inequality defined for any real number, for a particular real number value of c? Absolutely. If you divide both sides by negative 4, you have c as less than 0. And in this case, if you look at the discriminant, you have two real solutions. So our conclusion here is that for b equals 0, you can have two imaginary solutions. You can have one real solution, or two real solutions. It just depends on the value of c. If c is greater than 0, you have imaginary solutions. If c is equal to 0, you have a real solution. And if c is less than 0, you have two real solutions based on the sign of your discriminant. Alright, let's take a look at the b case. So for the b situation, we have a scenario where c is greater than, is less than or equal to 0. Okay, so in this case, we have to consider where c is equal to 0 and where c is less than 0. So let's take a look at the first possibility where c is equal to 0. Alright, so c is equal to 0. We know that a is always going to be 1. Now, what's the discriminant going to be? The discriminant, which is b squared minus 4ac, is going to be equal to b squared minus 4 times a, which is 1, times c, which is 0. So our discriminant is going to be b squared. Okay, because 4 times 1 times 0 is 0, and then negative 0 is just 0, so that part drops off. Now b squared is going to be the value of the discriminant. Now let's look at the three cases where it's negative, equal to 0, and positive, and see which one has defined values for the solutions of the inequality or equation. So for scenario number 1, where the discriminant is less than 0, b squared less than 0. Is this equation, is it defined? Is there any number that when you square it, it's negative? The answer is no. The square of any number, positive or negative, is always positive. Okay? So this situation here has no solution. You cannot solve it. There's no real number squared that is less than 0. Now, scenario number 2. Is it possible to square a real number and get 0? The answer is yes, because if you square 0, what do you get? You get if you square 0, you get 0. So this works perfectly. So in this case, where b squared is equal to 0, we are going to have one real solution, because b equals 0 satisfies this equation here. Case number 3, b squared greater than 0. Does this make sense? Do you have any squares that are positive? The answer is yes. All squares other than 0 are greater than 0. So since this is defined, we can conclude that for c equals 0, you can also have two real solutions. So these are the possibilities for c equals 0. Now, scenario number 2, what if c were less than 0? Okay, so for c less than 0, we're going to pick an example. Okay, so let's say, for example, c equals negative 1, just to simplify the whole process, make it a little bit more concrete. Let's take c equals negative 1, and a is going to always be 1. Alright, so we're considering where c is less than 0. Now, what is the discriminant going to be here? The discriminant, which is b squared minus 4ac, is going to be b squared minus 4 times a, which is 1, times a negative c value. We chose negative 1 just to help us out. So we're going to have b squared plus 4. This is the discriminant. Now let's take a look at the three cases and see which equation or inequality has defined solutions. So let's say we have b squared plus 4 less than 0. Does this answer make sense? Is it possible to have a real number that satisfies this inequality? To help us out, we can just subtract 4 from both sides. If we subtract 4 from both sides, we'll have b squared is less than negative 4. So the question now is there any square that is less than negative 4? The answer is absolutely not. There is no square that's negative. All squares are positive or 0. So this scenario has no solutions. Okay? Now let's take a look at the next case where b squared plus 4 is equal to 0. Is there a real value for b that satisfies this equation? To help us out, all we just do is subtract 4 from both sides, and we have b squared equals negative 4. Now, is there any number that you can square to get negative 4? The answer is no. Remember, all squares are 0 and above. Okay? So this is no solution also. And then case number 3, where b squared plus 4, the discriminant greater than 0. Does this make sense? In other words, if we subtract 4 from both sides, is it possible for a square to be greater than negative 4? Absolutely. All squares are greater than negative 4. So since this case works out, has solutions, when c is less than 0, you could have 2 real solutions also. Okay? So what's our conclusion for part B? For c less than or equal to 0, you can have one real solution, or 2 real solutions. There's no way you can have 2 imaginary solutions where c is less than or equal to 0 and a is equal to 1. Alright, let's take a look at part C. For part C, let's see what the nature of the roots are when c is, let's see what it is again, where c is greater than 0. Okay? For c greater than 0. Now to help us out, let's let c be a positive number. Okay, so let's have c equals 1, and we have a is always 1. Okay, so we're just picking a random positive number to help us really have a concrete understanding of what the solutions will look like for each discriminant case. Okay, alright, so what's the discriminant here? The discriminant, which is b squared minus 4ac, if we plug in the values of a and c, the discriminant becomes b squared minus 4 times 1 times 1, which is b squared minus 4. So this is the value of the discriminant. Now let's take a look at the 3 possible outcomes and see which one has defined values for b that can satisfy the equation or inequality. So for the first one, can b squared minus 4 less than 0, is it possible to solve this? If we add 4 to both sides of this inequality, we have b squared is less than 4. What this is asking is there any square that's smaller than 4? Absolutely. 0 square is smaller than 4. 1 square is smaller than 4. Okay? Any number that's less than 2, if you square it, the square is going to be less than 4. So this makes perfect sense. So since solutions exist here, that means that it is possible to have two imaginary roots when c is greater than 0. Alright, case 2, b squared minus 4 equals 0. Is there a real number that satisfies this equation? Add 4 to both sides, b squared equals 4. Can you solve this? Certainly, if you root both sides, you have b equals plus or minus 2. So this is defined. So what does this tell us? It tells us that it is possible to have one real root or solution, the same thing, whenever c is less than 0. Scenario number 3, b squared minus 4 greater than 0. Does this inequality make sense? I will add 4 to both sides. We have b squared is greater than 4. What this inequality is asking us is there any square that's greater than 4? Absolutely. 5 square, 3 square. Any number bigger than 2 or smaller than negative 2, its square is automatically going to be greater than 4. So this equation makes sense. Conclusion is that it is possible to have two real roots when c is greater than 0. Alright, so let's take a look at the last part. In question 21, it says, what is needed for the solutions to have imaginary parts? So if we take a look at our answers, we can easily determine what the solution is. The only times that we had imaginary solutions are when b was equal to 0, right here. And when else did we get imaginary solutions? When c was greater than 0, right here. Okay, so let's go ahead and answer the D part. Alright, so let's go ahead and write it down. So the solutions to the original quadratic equation x squared plus bx plus c equals 0 has imaginary parts when well, let's rephrase it. Can have, okay, can have imaginary parts, not automatic, special conditions apply. Can have imaginary parts when condition 1, b is equal to 0, or condition number 2, where c is greater than 0. So these are the two conditions that could result in this particular quadratic equation having solutions with imaginary parts.